Hello everybody, welcome to the second part of Combinatorics. In this video, we are going to talk about permutation of k elements in n elements. I believe I have called this variation in the last video, but that's not very common. Okay, let's start with the definition. Here we take a few of the given elements, in which the order of the items is important. Here, there are two ways we can further divide this. Without repetition, and with repetition. It will get easier to understand once we jump into the examples. Let's start with without repetition. Okay, let's jump right into an easy-to-understand example. In the case of no repetitions, in a permutation of k elements in n elements, where the order matters. I will clearly explain what order and repetition means after this example. Let's take a look at 5 different colored squares. Let's say that this is the best square competition, and we want to give the prizes from the first best square to the 5th best square, and we rank the squares like this. Now, the winners are of course only the top 3 squares. Now the question is, how many possible winners are there? The winners in this case are blue, red, and green. But it could have been orange and yellow too. Let's look at all the possibilities. To understand this part of the video better, you should check out the last video on permutations, which is in the link in the description. Now for the first winner, could be blue, red, green, orange, or yellow. So 5 possibilities. If we say blue won the first one, the second winner could be red, green, orange, or yellow, since blue is taken if the second winner is red. The third winner can only be either green, orange, or yellow. The 4th and 5th don't matter for us. This fits the definition since we are only taking few of the elements. That means that the number of possibilities of the winners is the multiplication of 5, 4, and 3. So, what do I mean when I say that the order does matter? Let's look at the 3 winners again. We can see that they are in a certain sequence or a certain order. Now let's look at another order of the 3 winners. Why is this order different? It's because the square that came first has changed. We consider this as a different possibility. So when I say that the order is important, that means that I consider these 2 orders as different possibilities. But you might say, hey, wasn't that obvious? Of course, we have to consider different orders as different possibilities. You are right, but it changes when we come to combinations. More on that in another video. Now, before we discuss about the second part of permutations with repetition, and before we go through what repetition means, let's find a general formula for permutation of k elements in n elements without repetition. So what was our result in the end? It was the multiplication of 5, 4, and 3. But that looks an awful lot like 5 factorial. But something is missing. It's the 2 multiplied by 1 in the end that are missing. That is basically 2 factorial. So that means that the multiplication of 5, 4, and 3 is 5 factorial divided by 2 factorial. Now, let's make a general formula. 5 is n, the total number of elements, and k is 3, the number of elements chosen. The 2 factorial is basically n minus k. So that means that the formula is n factorial divided by n minus k factorial. So, now coming to permutations with repetitions. That basically means that one color can appear more than one time. All the winners can be red. I believe that this is the easiest out of all, because that basically means that the first square can be all 5 colors, so can the second square and the third square. So the formula is the multiplication of 5 3 times. That is basically 5 to the power of 3. The general formula is then basically n to the power of k. Thank you very much for watching this video on permutations. The next video on combinations is coming up.